Okay, you're welcome back to the second part of the calculations involving acid-base reactions. So, there are also certain parameters that I would love us to know. Now, this is another expression which involves the acid-base reaction, another expression, another formula in resolving calculations involving volumetric analysis. Now this is the expression. Here we have Ca as the concentration of the acid in mole per dm cube, while you have Cb, concentration of base in mole per dm cube. Va, the average volume of acid used in cm cube. Now this Va, it is the volume of acid you get while carrying out the volumetric analysis. You get the average volume of acid used in the practical expression. After doing that, you can record that value as the average volume of acid used. Vb, you have the volume of base or the volume of the pipette. Now, we have two expressions, two values, two standard values of the volume of the pipette, because it comes in two expressions. You have the 20.00 cm cube and then you have the 25.00 cm cube. Basically, for a lot of schools, the 25.00 cm cube is what is mainly used. So you can use this or that, but always state or always write down the volume of base or the volume of the pipette used. This is a fixed value, be it that it is given to you in the question or not. This is what you use. And then we have Na, the number of moles of acids, and the Nb, the number of moles of base. So this is just an expression to guide us on how to be able to select the number of moles of acid and then the number of moles of base. So this is a reaction between tetraoxosulfate 6 acid and sodium hydroxide to give us sodium tetraoxosulfate salt, and then you have water. Now take note of this. Here, if there is no value behind this compound, it means it has 1 mole. There is no expression. So the number of moles of acid here is 1. And you can see clearly here there is a value here. This is the base. There is a value here. So we have 2 moles of the base. So you see 1 mole of tetraoxosulfate 6 acid reacting with 2 moles of sodium hydroxide. So we have the number of moles of acid here as 1, the number of moles of base here as 2. So let's go further. Now, they will be asking you to calculate the concentration of the acid and the concentration of the base. Whichever expression is given to you to calculate, you must work with the parameters given to you. So what I did here is to write down this first expression, which is written down here, and then we cross multiply, applying the change of subject formula principle. We cross multiply, and then we have this, and then we have this. So you see, making Ca the subject of formula, we divide this other expression by Va Nb. This is what we have. So each time you are calculating for the concentration of the acid, you have this expression, an expression between the concentration of base, volume of base, number of moles of acid, volume of acid, number of moles of base. And also for the concentration of base, this is what you have. So always take note of these two expressions. Take note of these two expressions. They are key expressions involved in calculating the concentration of acid and also the concentration of base used in the expression. So, thank you very much.